All right, so in this section, we're going to be talking about normal distributions, specifically how to find the probabilities in a normal distribution. Okay, so something to remember is that in a normal distribution, we're talking about a bell curve. Okay, so we've got a bell curve, and remember that in the peak, at the peak of the bell, is our average, and then we have our inflection points, one standard deviation to the left and one standard deviation to the right. So plus standard deviation. Okay, so these are things that we do need to know. So remember that a standard deviation in our cases will actually be given to us. Okay. Another thing to recall is how to calculate for position. So this is a normal distribution. If we want to change it to a standard normal distribution, we need the x or the this axis to be our z-axis. Okay, so we need to be able to calculate for the z-score. Remember, the z-score is simply x minus the average divided by the standard deviation. Okay, so let's take a look at this first example. It says the average speed of vehicles traveling on a stretch of highway is 67 miles per hour with a standard deviation of 3.5 miles per hour. So let's go ahead and actually write that part down. So we've got the average is 67 miles per hour, and the standard deviation is about 3.5 miles per hour. It says we select a random vehicle. We want to know what the probability that the vehicle is violating that speed limit of 70 miles per hour. Assume that speeds are normally distributed and are represented by the variable x. Okay, so the key word here is that normally distributed. That's going to be what tells us that that we can use the normal distributions. All right. So let's take a look at what the probability is that we're actually looking for. What we're looking for is the probability that whatever the car is, so our car is represented, or the speed is represented using x, is greater than 70. Okay, so we're looking at the probability that it is exceeding or violating the speed limit. So what we need to do is first figure out what the z-score is that corresponds with 70. Okay, so to find the z-score, so z sub 70, right? And the reason I'm doing this is because we will be dealing with multiple values of x, and specifically in example number 2, and I'll show you guys that here in a little bit. Okay, so we've got using our z score equation up here, we would say 70 minus the mean, which is 67, divided by the standard deviation, 3.5. And when we do this, we get approximately 0.857. Okay, so use your calculator, check me to make sure. But this is our z-score. So if we were to look at this standard normal distribution, okay, remembering that this middle part is 0, and we have -1, 1, and then 2, 3, so on. Okay, what we need to do is we need to figure out where this actually lies on our graph. So remember that the z-score is a position on your standard distribution. Okay, so 0.857 actually lies, it looks pretty close to 1, but not quite to 1, right? So we have that it's right about there. Okay, and the probability that we're looking for is that our x has to be greater than 70. So again, taking a look at this standard normal distribution, what we're looking for is the area to the right. So this is going back to section 5.1, but we're looking for the area to the right of this this point. So 0.857. Okay, so that's what we're looking for. We're trying to figure out what the probability is here. So remember that to find the probability, you're going to go to, you're going to hit second vars on your calculator. So second vars, scroll down to normal CDF, and you're going to fill in this information. Now, remember that the furthest to the left represents the lower, and the furthest to the right, which in this case should never end, will be your upper. Okay? So your lower limit should be 0.857, and your upper limit should be just a really, really big number. In this case, just use like 9,999 or something like that. Okay. Now, when you do this, you get that the probability is approximately 0.196. Okay. So we do want to be able to interpret these, and we're going to be doing more and more interpretations here. So what we could say is the probability a vehicle is violating the speed limit of 70 miles per hour is about 19.6%. Okay, and so that's what we're looking for when we're interpreting this, and we're gonna be summarizing our results more and more as we go through these. And we get deeper into the statistics. All right, so let's take a look at another example. It says that a survey indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes with a standard deviation of 12 minutes in the store. Okay, so let's go ahead and write that information down. So we've got a mean of 43 minutes and a standard deviation of 12 minutes. Okay, it says the length of time spent in the store is normally distributed and are represented by the variable x. A shopper enters the store. Okay, so part A, we're going to find the probability that the shopper will be in the store between each interval listed below. So let's go ahead and do that part. Okay, so number one, we want to find the probability that the shopper is going to spend between 22 and 52 minutes. Okay, so the way we're going to do that is first by calculating the z-score for each of those x values or each of those boundaries. Okay, so calculating it for 22 minutes would give us 22 minus the average, which is 43, divided by the standard deviation. This will give you a z-score of approximately negative 1.75. And then we would do the same thing for 52. Okay, so this would be 52 minus 43 divided by 12 is equal to, that's 0.75. Okay, and using these, right, again, remember that here's our z-score. Back here would be negative 1.75. Up here would be 0.75. We're looking for the area in between here. Okay, so that means that this is our lower limit, and this is our upper. Okay, and when we calculate this, we get that the probability is about 0.733 or 73.3%. Okay, now let's take a look at the second value. Okay, so this time it says more than 37 minutes. Okay, so we're looking for the probability that the customer is in the store for more than 37 minutes. Okay, so we're going to do the same thing that we did before. We're going to start by calculating the z-score at 37 minutes. So it's going to be 37 minus 43 divided by 12. Okay, and again, using your calculator to check, you're going to get 0.691. Oh, I'm sorry. You would get negative 0.5. Okay, and then using your calculator, again, kind of illustrating what's going on here. Okay, the z-score is behind the average. So here's the average, 0. The z-score would be somewhere back here, negative 0.5. And we're looking for the area greater than that z-score. So it's going to be back up here. So we're looking for all of this area here. So again, this would be our lower. Your upper would be some just really, really big number, because it's the never-ending shaded area. And when we type that into our calculator using that normal CDF, you get an area of approximately 0.691, or the probability of somebody spending more than 37 minutes in the store is about 69.1% chance. Okay. Now, looking at part B. Okay, so part B says, when 200 shoppers enter the store, how many of those shoppers would you expect to be in the store for each of the interval of the times listed? Okay, so 200 shoppers enter the store. If there's a 73% chance that that they'll stay in there between 22 and 52 minutes, what we're going to do is we're simply going to multiply 200 by 0.733 and see what we get out. So when we do this, we get approximately, when we round up, approximately 147 customers. Okay. And then part B over on number 2, we're going to do the same thing. So again, the probability this time is about 69.1%. Okay. So to figure out how many of those customers will be in there more than 37 minutes, we're simply going to take 200, multiply by 0.691, and we get out, by rounding up, 139 customers. Okay? So that's what we're looking for. All right. So the last example, using your graphing calculators, and I'll show you guys how to use your graphing calculators a little bit more thoroughly whenever we get into class, but it says triglycerides are a type of fat in the bloodstream. The mean triglyceride level for a U.S. adult 20 and older is about 97 milligrams per deciliter. So we have the mean is about 97 milligrams per deciliter. So mg per deciliter. Okay. And then to reading on, it says, assuming the triglycerides of U.S. adults are at least 20 years and older are normally distributed with a standard deviation. So we have our standard deviation here of 25 milligrams per deciliter. We randomly select a U.S. adult who is at least 20 years old. We want to know what the probability that the person's triglyceride level is between 100 and 150. So the probability of the person that we chose having triglyceride levels above the average. Okay. So what we're going to do is we're going to first calculate the z-score. So we're going to calculate z of 100. Okay. I'm going to leave this part to you guys, but you should end up with about 0.12. And then when we do z of 150, or the z-score for 150, we get about 2.12. Okay, and I'm going to go ahead and draw this again just to kind of reiterate what we're talking about, what this is representing. So we've got 0, 0.12 is about right here, so 0.12. 2.12 would be about right over here, so somewhere in here. Okay, and we're looking for the area in between here. Okay, so we're looking for the area in between those two values. Okay, again, you're going to use the lower limit is going to be 0.12. Upper limit is going to be right there. And when you do this, again, just check your work in your calculator, but it's approximately 43.5%. Okay, so let's go ahead and interpret this. Okay, so interpret. We would say the probability the person chosen has triglyceride, right? It is triglyceride levels between 100 and 150 milligrams per deciliter is about, and we said it would be about 43.5.